So, guys, sometimes at the beginning of this chapter, I promise to show you how to determine the charge, or we also said charge for metal. In case of non-metal, we call them oxidation number. So when I say oxidation number, they're kind of interchangeable with charge. I'm going to use these rules to determine whether something is reduced or oxidized by simply looking at what we call oxidation number, which is kind of similar to charges. So these are rules which tell us certain elements have certain charges. For example, rule number 1 says, if you are dealing with element like copper metal, silver metal, oxygen gas, copper, let's say nickel metal, iron metal, all of these elements have zero charge. Therefore, their oxidation number is zero. Why do elements have zero charge? Simply because they have equal number of electrons and protons. Now, rule number 2 says monoatomic ions. In monoatomic ions, we define oxidation number to be the charge of that ion. In other words, if I say the charge of Na plus is +1, that means oxidation number of Na plus sodium ion is +1. If I say the charge of chloride ion is -1, that means oxidation number of Cl in NaCl is -1. Rule number 3, it says oxygen in its compound has an oxidation number of -2. This is most of the cases. There are a couple of cases, small number of cases, where oxygen has a charge of -1. Example, in hydrogen peroxide, the charge of oxygen is -1, 2 -1 becomes -2, and the charge of the hydrogen is +1, 2 + 1 is +2, they add up to be 0. So this is the only exception, but normally oxygen has got oxidation number of -2. Let me go to the next slide, and you see here definition of hydrogen. Oxidation number of hydrogen is always +1. Is there an exception? Yes. There is one exception, and that is when hydrogen becomes a partner with a metal. These are called metallic hydride. So this is sodium hydride. In sodium hydride, remember we said the charge of sodium is +1 because it's in group 1A. Oxidation number is therefore +1. So hydrogen here is not and cannot be +1. In this case, the charge of hydrogen in metal hydride is -1. That's an exception. In majority of cases, hydrogen is +1. And then rule number 5, it says fluorine, which belongs to group 7, has a charge of -1. Now, other halogens in binary compound, they have a charge of -1. There is an exception. The exception is when there is an oxygen, then the charge of the halogen like chloride, iodide cannot be -1. We have to calculate that based on the oxidation number of other atoms. Rule number 6, it says compounds and ions in an ion or polyatomic ion, let's say, or in a compound, the oxidation numbers must add up to be 0. And you already know that. See, -1 + 1 must add up to be 0. In NaCl, you know that oxidation numbers are adding to be 0, -1, and +1. That's the rule that we have used so far to write a balanced formula for compounds. But if you have a polyatomic ion, in other words, can I say the charge of polyatomic ion is +1? It means that if you add all the oxidation number, the result must be equal to +1 charge. So if I say there are 4 hydrogens, that's +4. What is oxidation number of nitrogen in NH4, which is added to +4 from hydrogen to have a total charge of +1. Nitrogen has oxidation number of -3 in NH4. Or if I say, what is oxidation number of, let's say, all atoms in water? You say, we said hydrogen is supposed to be 1, so 2 times +1 +2, and we say oxygen is supposed to be -2. Do you see how they add up to be 0? So if a compound doesn't have a charge like NaCl, oxidation number must add up to be 0. If a compound is polyatomic ion, like phosphate, for example, the charge of phosphate, if you look at the polyatomic ion charges, you get a table actually from that. On the exam, you don't have to memorize. You see PO4 has -3 charge. 4 oxygens, 4 times -2 is -8. So what is the charge of phosphorus? To add to -8 to be equal to -3, do you get +5? So oxidation number of phosphorus is +5 here. +5 -8, you get -3. That is the charge of this polyatomic ion. All right, so let's go to the next slide. And on this slide, let me take this bar out of my way. It's zoom bar, which is bothering me. Let me actually make it disappear. Hide floating bar. Okay. So, guys, if I were to determine oxidation number of all atoms, I have to use the rules in the table. Do you remember the table of oxidation number? Defined oxidation number of hydrogen, so I know this, and define oxidation number of oxygen. So what is unknown here is carbon. This is a polyatomic ion. What is the total charge of this polyatomic ion? It's -1, right? -1. We know 3 oxygens, each oxygen has got -2 charge, so -6. And we know hydrogen is +1. So what is oxidation number? What adds to +1? And adds to -6 to be equal to -1. Is that giving you 4? If I get 4, +1 is 5, -6 is -1. So what is oxidation number of carbon is +4 here. Does this make sense? So let me show you again. Oxidation number is defined by the table of oxidation number is -2. And hydrogen is defined to have a charge of +1. So if I have 3 oxygens, 3 times -2, that's total oxidation number of all atoms of oxygen. And I have 1 hydrogen +1. What is oxidation number of carbon, which is added to the rest of the atoms to be equal to the charge of molecule? So you can solve this equation. And if you do, you see the answer is +4. So that's how you can determine oxidation number of an atom in a compound. And if you see this compound is converted to another compound where the charge of the carbon is reduced from +4 to +2, let's say, then you know carbon has gained electron, carbon is reduced. So that's how we can determine, simply by looking at the oxidation number, whether a compound is reduced and it is oxidizing agent, or is it oxidized and it is a reducing agent. Let me give you another example. Well, 3 more examples. You want to determine oxidation number of I here. Why? The table defined oxidation number of oxygen. The table said for metals, Na+ is in group 1 and is always +1. So sodium is +1. I don't know oxidation number of I. That is the question. Why? Do you remember on the table we said when halogens are coming with oxygen, their charge is not going to be like the charge of fluorine. The charge is not going to be -1. So let's see what is the oxidation number of iodine. Again, I'm going to say there is one sodium, that's +1. There are 3 oxygens, and each oxygen has oxidation number of -2. So what is oxidation number of I, which is added to 1 and 3 times -2 to be equal to 0? Where is 0 coming from? Do you see there is no charge here? You see there is no charge here. There is not -1 or +1. So overall charge of all the atoms in this molecule must add up to be 0. If you do that, you solve this equation, do you get +5? In other words, if I give +5 and -6 and +1, do they add up to be 0? So that gives you oxidation number of atom I in NaIO3. So let's look at another example. The table defined oxidation number of fluorine. It did not define oxidation number of I. So if I, what number should be oxidation of I to add to oxidation number of 7 fluorine to be equal to what? What's the charge? 0. There is no charge. So let's look at this. I have 7 fluorine plus oxidation number of I must add up to be total charge of 0. Can you solve this equation? So this is telling you oxidation number of I in IF7 is +7. I hope these make sense. How about looking at atoms here in K2, Cr2, O7? Can I say oxygen is already defined in the table? Can I say this is a metal in group 1A, the charge is +1. But it is chromium, which is a transition metal. It can change its charges. It can have different charges. I don't know the charge, but I can calculate it. What is the calculation? Can I say oxygen is defined by table of oxidation number to have a charge of -2, and we have got 7 oxygens. And potassium, it's a main group metal. It's group 1A. It always gets a charge of +1. So what is the charge of chromium? Where 7 oxygens, 7 times -2. 2 potassium, 2 times +1, plus 2 atoms of chromium, of which I don't know the oxidation number. But look at the overall compound. There is no charge. There is no number here. The charge is 0. So all these must add up to be 0. So can you solve this equation, which you have one unknown, and that is the oxidation of chromium? You get +6. So that's how you can determine oxidation number of an atom in a compound. Look at it before and look at it after. If oxidation number is changing, that means the reaction is a redox reaction. If oxidation number is going down, that means that particular atom is oxidized. If oxidation number is going up, let me correct myself. If oxidation number is going down, that means that atom has gained electron, so it is reduced. And if oxidation number is going up, the atom has lost electron, that means it's oxidized. That's how you decide to identify a redox reaction, and that's how you decide which element, which atom is reduced or oxidized.